All right. So welcome, everyone. Hope everyone's been having a great day and great time since last time I saw most of y'all. So a couple of quick announcements, and then we'll go on to Jay. So first off, I want to thank our sponsors. If you've been watching all along, I keep on thanking Modus and Tech Systems, even though right now they're actually not doing anything since we're all virtual. But they've been a part of our group for a very long time. And then Green Events and Technology is my little company that sponsors all this stuff, technically pays for the Zoom account and so forth. Just a heads up on upcoming meetups. So we got some good ones. We got a really good one tonight, but so August, we're going to do August a little bit early because normal third Thursday of the month will actually be in Copalooza. But on August 12th, Cameron Presley will be speaking to us about functional programming. We're also going to have, I'm drawing a blank of his name right now, but someone's going to be coming to talk to us, a quick 10-15 minute talk about commerce and how you could use that for your e-com needs. And then on September 17th, we just got this little name called Mads Torresen, who's going to be joining us. If you don't know who Mads is, you definitely know his work. So he's the guy behind C#. He didn't invent C#. That would be Anders Hallberg. But Mads has taken over the reins of C# for what, 5-10 years now. And so that will be a great talk. And he plans on sticking around for quite a while. So, if you have any questions, he's going to stick around for any questions you have afterwards. So that should be a lot of fun. Just some other groups. Well, I should say, if you didn't notice, we do have a new logo for Louisville.net. Curious what people think. Have actually a new logo for all the groups I run. Louisville Azure Meetup. So next week, we will have Michael Crump talking about Twitch, right? And how you can actually grow your OSS projects or your open source projects on doing live coding. That should be a lot of fun. Michael does a lot of Twitch streaming like I do. And then on August 27th, lo and behold, Jay Harris is going to be coming back. We can't get enough of Jay. And he's going to be talking about, basically deploying your code using Azure DevOps. So, and then other groups, particularly that I run. So, usually second Tuesday of the month. We did it a little bit different this month, but we have the Louisville IT Happy Hour. So it's just like what it sounds like. It's just a happy hour. Come and join us. No set topics. We have the Louisville Tech Leaders. Right now, we normally meet a couple times a month, but because of the pandemic, we're only meeting once a month right now. That's the second Tuesday of the month at 8 a.m. Yes, it's early. It's early on purpose. And that's meant for tech leaders. And that can mean whatever, whether you are a team lead, just a tech lead itself, whether, not even leading people, but leading the technology, or all the way up to a director or VP, like the two of us that run that group. And so we meet second Tuesday of the month, and it's open discussion, right? So things that are you have questions for others you're hoping for help with, or just general discussions. And then, the irony, the remote workers meetup right now is on hiatus. So this group just got started back in November, but it was really actually meant for remote workers to get out of the house. So it doesn't really work so well because we can't really get out of the house. So hopefully that will start back up sometime next year once we can actually be meeting up. But with all that being said, I'm a big believer. Don't stick to just the Louisville groups, right? There's a lot of great groups out there. And all these groups. I actually have not attended .NET, so I can't say I've attended all these groups so far. Vegas. But I had to put Jay's group in here. These all have great groups. Tulsa, I attend quite often. but it was cool. Like the .NET Southeast, that's Southeast London. So that was really cool to be able to attend that. A lot of other great groups to include. There's the .NET virtual groups, so that's run by the .NET Foundation. And really, they're not running the meetups. It's .NET Foundation groups are having their meetups, and they're being live streamed on YouTube. I just don't do that because I stream these on Twitch, and so and I'm not allowed to, as a Twitch affiliate, I'm not allowed to double stream that. So lots of great groups to check out. Just go to Meetup and you'll find these. The hard part about Meetup is it's searching outside your city is a little bit hard because it wants to default to within 50 miles and all that great stuff. But if you do work a little bit, you can find other groups. All right, so we are. I forgot how many days away are we from Codepalooza? Hold on, I got to get my browser out. We are 33 days, 12 hours away from Codepalooza. So it is coming up very, very quickly. I'm a little bit biased. I think you should register for it. Actually, I need to talk to Jay because I think Jay will also be there. Because sure enough, Jay, I have had a couple of people who had to drop out. We're taking everything online, right? And we're trying to do it as best as we can to have it as much as possible like a regular in-person conference, just online. And I was, this is what you'll get for everything. It's $150. I wish it could be cheaper, but it still costs money to run an event online. And I will say that caveat on the attendee t-shirt, that is if we get 500 attendees, and we do not have 500 attendees so far. But that's where at the price point we can afford to do that. With that being said, and so far sponsorship's been slow, but if we get sponsorships, the intent is actually use that sponsorship money to offset, to basically refund folks. But so at the end, the idea is to whatever it really costs us to run it is the end ticket price. All right, a couple other little things. So just self-promotion. Every weekday, I stream on Twitch on TaleLearCode. And right now, it's a lot of interviews. I'll talk about that here in a moment. But it's just side projects I work on that I normally do. I'm on there. So the big focus for last several weeks has been a Gremlin ORM. The Gremlin is a graph database, and I love graph databases, and I really like Gremlin. The problem about Gremlin is not the easiest thing to work with. Everything is you have to string manipulate to get your queries built up. I'm building a simple ORM that will actually be able to handle that for you. So that's a lot of fun. That's 11:30 Eastern. You can go to TaleLearCode.tv or twitch.tv/TaleLearCode. And along with that, like I've been talking about, we're doing a lot of interviews. So, here's the list you can see I've done so far. And these are Codepalooza speakers who I'm interviewing, not always at 11:30, sometimes they're at different times. These have been a lot of fun, and we still have quite a few left. So you can go to the Codepalooza site, look at, go to conference, and then you'll see speaker interview series. That has the most up-to-date list of these interviews. And then I do put these on YouTube, so you'll be able to watch. You can actually go to Twitch also, but the thing about Twitch is actually after 6 days, the recordings leave, whereas YouTube, they're there forever. So definitely check these out. This is a great way to learn about the speakers we have at Codepalooza. And these have been a lot of fun. These have been so much fun. I'm going to continue to do these after Codepalooza. Not as frequent, but 1 or 2 a month type thing. Because they've been a lot of fun learning about other speakers. All right, and finally, we can't go to I keep the slide in here because I need to always remember we're going to go to BJ's. We can't go to BJ's anymore, at least for hopefully not too much longer. But we do stay online, and it's completely optional. And I'll stay here as long as you want. Well, that's not true. about 1 o'clock. If you're still here, I'm going to get off, but I'll leave there have been, sure, Jay, you laugh. I've had to say, folks, hey, I'm leaving. I got to go to bed.
Nice.
But definitely, if you stick around, and we'll talk about whatever you want. I will say, talking about the whole can't go to BJ's and everything. I have a feeling I'm about to make this decision. I think for the rest of the year, we're just going to be online, and basically try to shoot for, hopefully early next year we can go back in person. But I need to start scheduling things, and I think it's just going to be easier to just figure we're going to be online for the rest of the year. So I haven't fully made that decision yet, but I'm just about to make that decision. I think it's just going to make more sense. So that I reached out to Jay about a month ago. Hey, Jay, I would love to have you come speak. And Jay was like, hey, that'd be awesome. I'm not purposely putting words in Jay's mouth, but Jay does really like coming to Louisville, even if it's virtually. So it's great having him. And I think this is a great topic. That's why I picked this one out of the couple I could have picked. And with that, I'm going to turn it over to Jay, which actually, hold on a second, Jay, I did not make you host yet. Let me do that so you can share your screen. There we go. All right. So Jay, you're now co-host. Now I turn it over to you.
Yay. If I can remember to pin myself. Hi, I'm Jay Harris. I'm in Vegas. Have a consulting company, Rana Software, out here that I've had forever. You can tweet me, follow me, whatever else, at Jay Harris, pretty much everywhere. Share screen. I want that one. It's not in it yet, but now there should be. Hopefully you see my title slide. So yeah, hit me up on Jay Harris anywhere. And I encourage you throughout this to, if you feel like tweeting about it, use hashtag database confidence for any comments or questions that you may have tomorrow. Sure, we're, might stick around afterwards after the talk is done, but inevitably, Murphy's Law dictates even that you will come up with your best question after we all hang up. So feel free to hit me up at Database Confidence on Twitter to help with that. So yeah, I'm Jay Harris. I'm a coder. I'm an entrepreneur. I've been recognized as a Microsoft MVP and a Microsoft Regional Director. I've been doing this stuff for over 20 years. I've been a speaker for 13, a business owner for 12 now. And during all of this time, as a professional programmer, as a professional in IT, I've experienced that our most common source of anxiety in our applications, in our source code, is in the database. That's the source of so much of our pain. So I wanted to create this talk to help us get through that, to help us find some confidence and get rid of that anxiety inside of our databases. So as far as what this talk is, it is going to be focused on relational databases. This talk is going to be about .NET Core and C#, though these concepts and the tools that I'm going to discuss will apply to full framework .NET. We're not focusing on it for the next hour. And this focus is also going to be partial towards the heavy ORMs, like Entity Framework Core and Hibernate. What it's not is it's not going to be SQL focused. We're not going to be getting into SQL. We're not going to be getting into the language. We're not going to be talking about database security or SQL injection or any of the attack vectors into SQL Server. This also is going to have no applicability into non-relational NoSQL databases and database engines. Any specifics, any samples are not going to include the lighter ORMs like Dapper, or Petapoco, and there's going to be nothing in here that's direct ADO. Though these upcoming concepts might apply to those areas, we're keeping this focus very tight. We're limiting our scope for the next hour just so that we can get the information across. And throughout all of this, if you have any questions, I absolutely encourage you to just unmute your mic and, hey, Jay, fire that one away. Since I have 3 screens worth of presentation now in front of me, I'm not going to be able to see the chat windows or things like that. So just feel free to unmute your mic and interrupt me all you like. So why do we have this anxiety? Why are we scared? We have these massive databases that have been around for decades, and they frighten us. But at the same time, we have elements of our code that have been around for just as long, and we don't fear that old code, that old C# nearly as much as we fear our old database. And it's not a technology stack thing. It's not our fear of SQL Server that is causing this anxiety either, because many times we even just have simple CRUD tables, and those CRUD tables are bringing just as much anxiety as the complex stored procedures or views or other heavier things that are inside of the SQL technology stack. So we have this fear, we have this anxiety, and we need to move beyond that. But instead of focusing on what we don't want, instead of focusing on our fears and anxieties, let's focus on what we do want. What gives us confidence? Perhaps basing this on what gives us confidence in our application code on the .NET side and the C# side. Well, of course, one of the biggest things we have that gives us confidence in our application code is tests. Unit tests, integration tests, any type of test. It doesn't matter. Some sort of automated testing system to make sure that our application code is doing its thing. But, of course, we usually have 0 tests involving the database. In fact, many experts, many even leaders inside of the industry have been telling us for years, don't test the database. Don't test the database. Don't bother testing the database. You're wasting your time if you're testing the database. So we've almost been trained to not even bother with this confidence system that we have around the database. We also have automation on our application code. We can click one button and it'll compile the entire application. Many times we can click one button to make a full release, a deployable release. So we can click one button to even deploy the code, even straight into production. We have many of these complex tasks around our application code have been turned into a PowerShell script or a Bash script. But have we done any of the same stuff to the database? Of course not. Often, our production deployments of database modifications are using some sort of third-party schema comparison tool that just diffs, I don't know, a test database with a production database, and we hope, hey, that looks about right, kind of. Yeah, let's move that into production right now. Sounds good. A repetition around all of this stuff in our application code also gives us confidence. We have source code. Most everybody now has source control. They're using Git for their source control. If whatever the current revision is right now, the current Git revision, if I compile that Git revision now, or if I check out this Git revision a year from now and compile it, it's the exact same result. And because of that, whether if I'm using this Git revision now or a year from now and run the unit tests, it's the same result. And because of that, if I take this Git revision now or a year from now and deploy it, it's the same result. Our code base has this repetition built into it. It's consistent because of our change tracking and because of our tests and because of our automation. We have this repetition built into our code's infrastructure, but our database, we have no tests. There's no repetition in our tests. There's no repetition in our deployments. There's no repetition in our validations. That schema diff that we do with that third-party tool when we're getting ready to deploy from test to production, well, that schema diff might be a different result tomorrow because something in the test database changed. It might be different the week after that. There's how can we guarantee that, like with the database, that a week from now or a year from now, that we can still generate the exact same scripts, not just for the initial deployment for test to production, but also redeployments into production, which gets us into that fourth element of recovery. What happens if things go wrong? How do we roll back? For our application code, we just reinstall that last release. It takes, I don't know, a few minutes to redeploy the code that we just had in there. It's easy. But our database, do we have the migration scripts that can roll back a release? Have they been tested? Have they been automated? Have they been proven through repetition? Say if you don't test your restore, do you really even have a backup? We don't have these recovery processes for our databases either. In many cases, even for the initial deployment into production, if something goes wrong and we have to roll back, if we have to recovery is a full restore from the backup we made before we started the deployment process. If we remembered to make a backup of the database before we started our deployment process. So we know what gives us this confidence. We know what gives us the confidence in our application code, and we can apply those same principles to our database. We don't, but we need to. That's how we're going to get rid of this anxiety that we have around our database. But how do we do that? How do we really make that happen? Well, first and foremost, we have to build a testability into the system. We have to have functionality in place that can be reliable under test. Functionality where failures are issues with the code, our production code, not just a failure within the testing process. And that's an important element, because just as much as it's important to have tests, we need to make sure that if a test breaks, it's a problem with the code, not a problem with the test. We have to make sure that things are verifiable. Once we have the code base into a point where it can be tested, we have to actually test it. We have to actually write those unit tests once the code base is in a position where it can be tested. But of course, testing it in a sensible way. It needs to be a repeatable process. We need reliable results. Those tests need to come up with repeatable, reliable results in order for us to begin to have confidence in this testing platform, in this automated testing platform, which ultimately is confidence in our database as a whole. So how do we begin this lofty idea, this lofty goal, to use corporate buzzword bingo? Well, let's start with schema validation. Let's make sure that all of our systems have the exact same expectations of each other. And I qualify that because this isn't even to the point of making sure that our systems share our expectations. This is just making sure that the system meets its own expectation with itself. So making sure that the database schema that we've prescribed inside of our C# models, inside of our classes, match what's actually being presented in the database. Because those are going to be runtime exceptions. Right? If we have a nullable type inside of our C# model, but that column is not nullable inside of the database, things are going to blow up as a runtime exception because we're trying to jam a nullable value into a non-nullable column. That's not going to work. We want to try and catch as many of those issues, as many of those errors and concerns long before the deployment process, long before the application is executed by the great international test fleet that is our user base. So two options that I'm going to discuss for schema validation. One is schema validation using NHibernate, and one is using schema validation in Entity Framework Core. To start with, for NHibernate, and of course NHibernate is NHibernate on NuGet as well. This functionality has been around since NHibernate 2, which is quickly approaching 10 years now, even though NHibernate is currently on version 5.2.7. And all of that stuff, the beginning stuff goes through a class called Schema Validator. or more specifically inside of a test would be schema validator.validate. Now, this is not NHibernate's model validation engine. This is schema validator, not model validator. This has nothing to do about making sure the age property on your user class is at least 18, or making sure that the password has a mix of uppercase and lowercase and special characters and numbers and whatever the new rule is for this week. This is just making sure that your data definition layer matches what is the expectations are in your entity mappings, in your models, in your classes. So all of this runs through that schema validator. You'll pass in your session configuration. If you're used to Entity Framework, that's very similar to your model configuration, your database context. So you'll pass in your session configuration and simply do validator.validate. So you'll need an instance of that schema validator class, and once you have it, just execute its validate method. That will output some sort of exception that's going to have off of that exception a laundry list of all of the exceptions. It doesn't just blow up on the first issue that it encounters with validation. It validates the entire schema, comes up with a laundry list of all of the issues that it's encountered, and all of those issues are available inside of that exception. If we were going to wrap this inside of a normal test, that might look like taking those 2 lines of code, wrapping it inside of a try-catch block to trap that schema validation exception, and just looping through the exceptions validations errors collection and outputting that validation error to console. Turning this into an Entity Framework core schema validation test instead of NHibernate, rather than newing up a schema validator instance and running validator.validate. These methods are available right off of the context. So right off of database context, we have context.validate schema. Now this is available for Entity Framework Core, anything since version 2.1, even though Entity Framework Core is, as of about 2 hours ago, on 3.1.6. However, I do want to point out that this is available for Entity Framework Core. This isn't available from Entity Framework Core. This is not functionality that's available out of the box inside of Entity Framework Core. There's nothing released by Microsoft that covers schema validation through any of Microsoft's released public auxiliary libraries. So we wrote one. We've got a library, it's open source, available on GitHub, Entity Framework Core.validation. It began with version 1.2, which covers Entity Framework Core version 2. It's currently in 1.3.0.2, which covers Entity Framework 3.0. So this validate schema method is an extension method off of the database context. We wrote it so that it operates exactly as the NHibernate stuff. If things blow up, it throws on an exception. That exception has a collection of validation errors that meets everything on the schema that's not in place. And like with before, you could wrap this inside of that try-catch block, loop through the collection, and put them all to the console, or whatever most appropriately fits the needs of you and your testing framework, your testing consumption. So as a part of validating the schema, we're also going to need an engine. We're going to need some sort of database to run this thing against. We've got to have an actual database, right? If we're going to be able to do the comparison of the data definition layer against what's in our C# models. There's a lot of options available for the engine that you can run your tests on. SQL Server, Entity Framework Core has an in-memory engine. SQLite has an in-memory engine. And of course, SQL Server also has its local DB option. Now, oftentimes, someone might say, well, why don't we just use the same as production? If we're using this SKU of Microsoft SQL Server inside of production, wouldn't we want to do that same thing? Even Martin Fowler in his tenets of continuous integration says to test in a production-like environment. Well, that might work But we can use SQL Server as a standalone engine, just like we have production. It's tempting because it already has the same addition to SQL Server installed often locally on our localhost machines, on our developed machines, or at least some sort of shared dev instance that all of the developers can use and our localhost code is pointing to. But the problem with this is it's very heavy-handed. It's very heavy-handed using the full SQL Server engine in that behemoth for something as recurring and as frequent as unit testing. This is also going to be subject to collisions from multiple developers, because at the end of the day, there's probably just going to be one My Application database. And if two different developers are running their tests at the same time, there's a lot of opportunity for those tests to collide and give false results, because they're both trying to manipulate the database at the exact same time in predefined testing ways that might not be similar to what you have inside of an actual production environment. For example, maybe you have a unit test that is testing out adding in a new user into the database, and you might have in your unit test just some hard-coded email address or some hard-coded username. That's going to blow up on a unique constraint on the user if both users are hitting that unit test at the same time. There's even opportunity for concurrent tests to step on each other, because maybe you have a test that one way or another is clearing out the unit test or the user table as a part of its execution. So it could have race conditions against the unit test that is creating a user inside of the database. There's lots of opportunities for things to go wrong if we're all using one common installation of full SQL Server. So what about putting SQL Server in some sort of container? That would get rid of our collisions from you and me both executing our unit tests at the same time. Well, Docker's still heavy-handed. That's going to take a lot to get a Docker instance that has a full, or some sort of container instance that has a full database engine spun up inside of it. And it's also going to be slow to get all of that stuff restored, all of the appropriate data put in place inside of the container. And it's still going to be subject from the collisions of having multiple concurrent tests that are where, even if they're tests that you are executing, those tests are running in parallel and both trying to act upon the same table at the same time. So that gets us into something like Entity Framework Core's in-memory database. It's designed for unit tests. It's designed for that isolation. It's very fast. Each test can absolutely get its own instance, so it would eliminate any of the collisions, whether it's developer versus developer collisions or test versus test collisions. All of that isolation has been handled. But the problem is, though this might work for testing the functionality of your system, this absolutely is not going to work for schema validation. Entity Framework Core's in-memory database is not a relational database, so it's not going to be able to manage all of the different schema-based stuff, the schema definitions that we're really going to be relying on in a schema validation test. SQL Server's local DB. Local DB is going to create a copy of your, essentially it's going to create a copy of the database inside of the bin of your test assembly, of your test project. It certainly is going to be isolated from other developers, reducing a lot of those collisions. And local DB is also very light. It's very fast. Issues with SQL Server local DB is it's not cross-platform. Now, keeping in mind all of your testing infrastructure, not just your local development patterns. So even though all of the developers might be on Windows, maybe your DevOps environment is not. Maybe since you're building this stuff on .NET Core, and .NET Core is cross-platform, even though everybody's developing in Windows, the continuous integration system might be sitting on a Linux box somewhere, or using a Linux VM inside of Azure DevOps. So the lack of cross-platform is also going to get in the way. Also, under default configurations, it's still just one database for your test assembly. And finally, SQLite in memory. SQLite in memory is cross-platform, so it's going to work on any operating system that you want to run your tests against. It's going to give full test independence, full test isolation. Every single unit test is going to get its own copy of the database, assuming you spin it up that way inside of your test fixtures. So there's not going to be any collisions. It works, but there's some caveats. It's low referential integrity inside of SQLite. Foreign keys are not so much of a thing here. That's going to be fine for many, many areas of validating your schema, validating your database code against your models, but it's not going to be enough for a full comparison. Most of the stuff you can get by without making sure that there's an actual foreign key between, I don't know, the user table and the organization table, however you have your foreign keys set up. So this will work for most scenarios, especially considering that we have, if you need cross-platform needs. But if you don't care about the cross-platform stuff and your continuous integration stuff, we can just go back to SQL Server Local DB. Now, as I said, the SQL Server Local DB stuff is going to want to just give you, by default, one database name, but we can get around that with the fixtures, just as we're going to have to create a new connection for SQLite. If we're using SQLite for our engine in our unit tests, we'll just randomize the connection string, use some sort of library or a line of code that will create some sort of random name inside for our database name. It'll be stored in our local DB, and that way we can have full isolation in our tests as well. So those are my recommendations for the engines, is going with SQLite in memory or going with SQL Server Local DB. And that gets us through.
How about SQL Server running in containers?
With not SQL Server running in containers, because it still doesn't provide us our isolation for unit testing. And it's going to be much heavier than the needs that we need for running unit tests, many unit tests fast.
Sounds good.
With the schema validation, this gets us validation on our column names, making sure that they all match up, making sure those types match up. Sure, most of the time we can get away with storing a long inside of an integer-based number, but once in a while, especially in an actual production environment under runtime, we're going to be outside of the confines of a normal integer, and things are going to blow up. So we need to validate that even an int64 on one side is an int64 on the other. We need to make sure that if there's if a type can be nullable inside of our C# model, that the nullability matches on our database. We can verify that those keys are in place. Of course, with the caveat of foreign keys are tougher to manage inside of SQLite. We can make sure that our index is there and make sure that our views are all configured the same as well. So with our schema validated, we know that our schema matches between our models and our classes versus our database. We can extend that further into automation and testability around our migrations. So two examples, two different setups, configurations, libraries, whatever, for our migrations, going over Entity Framework Core's migrations and a third-party library called Fluent Migrations. So with Entity Framework Core, the migrations have really been there and robust since 2, even though Core is currently on 3.16. The documentation will say just @-migration from the package manager console, @-migration with whatever your migration is. Meh. I'm not really a fan of the add migration style syntax through PowerShell for Entity Framework migrations. It's going to build a lot of nonsense into your migration stuff. It's also going to build a local snapshot of your model so that next time you run migrations, it's just diffing that snapshot against what all of your C# models and classes want now. So if there are further changes to your database that are outside of that one-time snapshot, you can run into some trouble. The PowerShell version of Entity Framework migrations have much more of an expectation that these migrations are the only way that the database is ever touched, that they're all together, that there's one application to one database, and this one application's migrations are the only thing that ever touches the data definition layer. And of course, at least in my experience, that's almost never true. There's other modifications that are being made. There's other tables or views that are being created that are outside of this application's context, especially in a world where we may have multiple applications that are all touching the same common shared database. Now, the migrations that those PowerShell scripts are creating are still pretty straightforward. We can just build them manually. It's not that hard. This would be an example of one of those migrations that were generated by add migration and that we can build themselves. It starts out with a protected override void up. Up is the migration, is the deployment method that's going to be executed to create the new tables and columns and alterations that we need for this database. And it takes in automatically a migration builder. It's very similar in concept to the model builder that's on the database, the Entity Framework core database context itself. From there, off of that builder argument, we'll just do create table, passing in whatever the name is of the table that we're going to create. That method also takes in a columns argument. And for it, it has an anonymous type that lists all of the columns that we're going to be adding to this brand new table. So ID would be the name of this first column. And then off of that, table is going to be table.column and whatever the type is that you're going to be passing into the columns. And this one will be using a GUID for our identity column. We can also pass into that column method a whole slew of additional properties that we might be adding. For our string columns, we might say what their max length is, or we can always set its nullability. Its nullable is false by default, but we can turn nullability on for a column. For the ones that aren't nullable, we can specify for what the default value is. So if we have a Boolean column, we can just hard code that default value to false. And then in addition to that columns argument, we also have a constraint argument where we will define what all of the various keys and constraints are that are going to be on this table, specifying the name of that constraint and then what column that constraint is going to be associated with. Still, overall, it's not that complex for building out a migration by hand, yet still much more, I think, robust than the PowerShell stuff is going to create for us. Certainly, since there's a protected override void up, there's also a down. Down is our rollback method. We would have very similar functionality to go put the database back in the state that we wanted it prior to this migration being executed. So since the up created the organization table, this down method is going to drop the organization table. There's plenty of other methods available for altering columns, for adding columns, as well as if we need to get down into raw SQL, that's available to us. We can just do builder.sql and pass in a SQL statement and execute some raw SQL when if the time comes. So from that up method, as well as our down method, we will wrap all of that inside of a class that derives from Entity Framework's migration class. That class will also be decorated with two arguments. One is the database context that this applies to. So that's going to be most useful in places where we have multiple different database contexts, perhaps one application that's talking to several different databases. That way, Entity Framework knows which of those databases, which of those contexts, and with it, which of those connection strings that this migration is going to be applied to, and a migration attribute that's going to get a unique number. These are going to be executed in order. So since these are all executed in numeric order, a common recommendation is to just use the current time. Use your current timestamp and type it all out whenever you created that migration. So if this migration was created last May on the 29th at 3:20 p.m., we'll just label the migration as 2020-05, 29/15/20. You don't have to use the timestamp, but it's a good recommendation. Rather than just using whatever the next sequential number is, starting with 1 and then having a migration 2 and a migration 3, I recommend against doing that because if you and I both created a migration at the same time and then we went to go push code, we don't get around till pushing the commit into Git until, I don't know, tomorrow morning sometime. But when we both created the class, we named it migration 2. Well, now we have 2 migrations that are both migration number 2, and they're going to collide with each other. But the likelihood that we happen to create this migration at the same minute by using a numeric timestamp, that's not likely to happen. So timestamp is certainly a recommendation. In addition to Entity Frameworks migrations, also have Fluent Migrator. Maybe you're using some sort of, maybe you're not using Entity Framework Core. Maybe you're using Dapper or Petapoco or NHibernate. Fluent Migrator is separate from all of them and can apply to just making migrations against a relational database. It doesn't care. So whatever your ORM is, or if you're using just straight ADO code, you can use Fluent Migrator as your migration system. This functionality has been around since Fluent Migrator version 2, even though Fluent Migrator is currently on 3.2.6. The syntax is very similar. So we still have the up method, override for up. But this one, rather than all of the stuff about a builder and anonymous types, we're going to have a create method that's global to that's a part of the class. So create.table, passing in the table's name, and everything is a series of extension methods after that. So creating our table with a column that's named ID. That column is going to be created as a GUID. It's going to not be nullable. And it's going to have, this is going to be the primary key of this table, giving it whatever the name is of that constraint. So PK organization for it being the primary key on our organization table, whatever convention we want to use for naming our primary keys, any of our constraints. I do like this since it keeps the constraints with the columns. I find that more beneficial with grouping all of that stuff together rather than having the separate constraints parameter inside of our create table method. Just like before, still similar syntax inside of Fluent Migrator. We have our public override void down for our rollbacks, where we have all of the same functionality available to us. We can even test to see if the organization table exists before we delete it. This is another thing I like because this uses the more normalized verbs rather than SQL-specific verbs for all of its functionality. Where Entity Framework Core is using terms like drop table, Fluent Migrator just uses delete. I find that helpful for if developers are participating in the migrations and they know what they need to create, but they don't necessarily know what the exact SQL syntax is. Maybe they didn't learn that drop table is the command inside of the SQL language itself. Maybe they're not familiar with SQL language, but they still know that what they want to do. I want to delete the organization table. I don't need it anymore. So I do like that about the language, the actions, the verbs that it is used. Of course, as before, altering tables, unlike Entity Framework Core, where alter column and add column are 2 completely separate commands, now it's just altering the table. And the extension methods off of altering table allow you to alter a column or to add a column to the list of modifications for that table. And of course, dropping down into SQL Server if we needed to. Still all wrapped up in one class that derives from, in this case, Fluent Migrator's migration instead of Entity Framework Core's migration class. Still with a migration attribute with a timestamp identifier. This one also allows you to give it more of a human readable name to that migration. And that human readable name, as well as its numeric identifier, will both be put into the output logs when this stuff is executed. So that gives us not only schema validation, but it also gives us repeatable migrations for our code. We're not relying on some third-party tool to just diff the test database and the production database at the time of deployment. We're not relying on somebody, some developer that happened to write a SQL script and, I don't know, they put it in a Slack channel. Make sure you go execute this script before when you're deploying to production. We've all done that as well. So this gives us stuff in code that's repeatable, that's reliable. It's going to be committed into Git so that we can get back to it a year from now if we need to get to that revision. So now with these migrations, this gives us migrations for tables. This does not give us migrations for views, for functions, for stored procedures. It's just tables and their columns and their indexes and their keys and constraints. It's about data structures, not query structures. So, yeah, and it gives us that automation. It gives us that repeatability and recovery so that we have some confidence in this when it's time to deploy. But most importantly, it also gives us more validation around the system. So we can combine these two concepts together. We can combine together our schema validation as well as our migration system. So again, relying on Fluent Migrator. This is with additional functionality that came with Fluent Migrator 3. So now if we were to put some sort of system in place, maybe a unit test, that we could go and execute all of our migrations and then run validation on it post-migration to make sure that the output, the result, matches exactly what we want. So for creating some sort of code that would do this in a repeatable and testable fashion inside of Fluent Migrator, we need a little bit of code. To begin with, we need a new service collection and setting up the core services. This is going to be very similar to setting up a service collection in like a ASP.NET Core website. Inside of that startup class, you're going to have things for setting up all of your dependency injection context, that service collection. So we're going to need that here too. So create the collection, add the foundational, the core Fluent Migrator stuff, the base stuff to it. We're going to configure the runner. The runner is the thing that's actually executing the migrations. We're going to tell it what type of database we have, because we're going to take this C# based code, right? We're going to take create.table organization, and we're going to need to translate that into a specific flavor of SQL Server, because SQLite is going to be a little bit different than SQL Server. It's going to be a little bit different than MySQL. So by configuring the runner, we can tell it what sort of flavor of SQL that we need to execute when we're actually running this against the database engine that we've chosen. And we also need to tell it where all of our migrations are. So with this example, the with migrations in method passing in some sort of assembly or collection of assemblies that are housing all of your Fluent Migrator migration classes. And then we're done. .build service provider. Again, very similar to the stuff that we're going to do with things like web host in an ASP.NET Core web application. Now, unfortunately, this won't quite work for our needs in testing. This is more than enough if we were going to manually build, I don't know, a console project by ourselves that would run our migrations. Of course, it does come with its own migration tools built in, but this won't quite work for our testability. And the reason is we're using things that we're using in-memory databases. So for example, that SQLite in-memory database, it relies on the guess a good way to put it is it relies on the open connection to maintain the pointer to the memory space that's holding onto that database. An SQLite in-memory database, it goes away when the connection is closed. All that memory is deallocated once the connection is closed. So normal migrations, if we were just going to go to a command prompt or a bash prompt and tell this thing to run migrate, well, Fluent Migrate is going to open up a brand new connection, run all of the migrations against that connection, and when it's done, close that connection. But we don't want it to do that stuff because we want to give it a connection and to maintain that connection when it's all done. So we're going to have to also override the test processor for that testability by deriving from whatever test processor that we're actually going to be running against. So this is going to match the flavor of SQL that we just set up. In this case, we're going to be overriding the SQLite processor. We're going to give it a constructor argument for the connection, because we're going to define that connection ahead of time, especially so that we can maintain it afterwards. And we're going to also have to override its ensure connection is closed method and turn that into a no-op, turn that into a do nothing, so that even though its internal code is going to say, okay, we're done running the migrations, go close the connection, we don't want it to do anything. And we want it to think that it closed the connection, but to not actually close the connection. So a few lines of code that we can just put on a gist somewhere in GitHub and just copy and paste it in when we need it and never reference it again. A few extra lines are into the dependency injection setup. We just need to set up into dependency injection our database connection, set up that processor. So we're going to add our test processor class into our list of services and say whenever something wants a migration processor, give it the one that we just created. And then extra configuration step to say the processor ID is going to be the test processor in the class that we just mentioned. And again, most of this is going to be code that we create one time only when we're first creating our suite of unit tests, our unit test project, and then we're never going to touch this code again. Now for testing these migrations, starting out with a test for a new database, we'll have some sort of test method, fact for X, whatever your unit testing framework system is. We're going to go get from that service provider that we just created, hey, I need a migration runner, because the runner is the type that actually executes our migrations. And then we're going to run its migrate up method off of the runner. That will run through all of those migration classes that you've given it, because you specified, hey, this is the assembly that migrations are in. Execute all of them. And we can create whatever our assertion library is. We can create some assertions off of that when we're done to make sure that it's all there. So in this case, we can get to runner.processor that'll use our existing open access to the table to see if a table exists. Just like those methods that we had inside of our migration class itself, to see if the organization table exists for a given schema, and blow up if it's not there. We can set up using things like rollback, because we had migrate up to roll back to the very beginning. Roll back to version 0 is the start. So again, this is a new database. If we rolled back to version 0, in theory, we should have an empty database again. And then through that, we can run another assertion, this time assert false instead of assert true on if the table exists. Because we rolled back to version 0, we went back to an empty database. That table shouldn't be there anymore. Now, why would we want to make both of these tests? Why not just the first one? What do we care about the second one? Well, it's sort of like making sure that we restore a backup to make sure that the backup works. We want to test the recovery process as well as the deployment process. So the first one will allow us to run all of the migrations inside of our system, inside of our application. The second one will also execute all of their rollback functionality to make sure that we put the database back into our known state, our known pre-deployment state. And then further, combining both of those concepts together, we can take our runner.migrate up and run this against schema validation. So in this case, context.validate schema for that entity framework-based setup will, after we've executed the migrations, run our entity framework schema validation against the result of our database and make sure that all of our C# model and class expectations meet what's actually presenting itself inside of the database. Now converting that over, now this is this is doing everything based off of a Fluent migrator-based system. If we were going to do this inside of entity framework, of course, we wouldn't have to go create all of the service collection stuff. That's going to be happening elsewhere in wherever you're initializing your database context, your DB context instance. So we would just need a context.database.migrate for our entity framework migrations. Now, if we want to do all of this stuff inside of Hibernate instead, well, we don't have any framework migrations, so we got to go back to the Fluent migrator type syntax. But then with this schema validator passing in a session configuration .validate, this one won't work because it runs into the same problem with the database connection as we had with Fluent migrator. The schema validation validator .validate also wants to open up a brand new connection, going and getting the connection string from wherever your app settings are, initializing a new connection, and none of that stuff's going to work for our in-memory databases. So that's not going to be a valid option, but it's only a few lines of code still. Again, touch it once stuff to get around that. Schema validator.validate. This is what it does under the covers. It just, instead of passing in an existing DB connection, it goes and opens a brand new one. So 3 lines of code, one for the dialect that we're connecting to, that flavor of SQL, if we're talking to SQL Server or MySQL or SQLite, and a database metadata that takes in that dialect and our connection string, and going against session configuration.validate schema, instead of validate schema, passing in the session configuration.validate. But it's all around that pre-existing DB connection that you've already opened elsewhere and passing that around. So we've gone through schema validation, we've gone through migrations, we've gone through combining both of those together. Last is data validation. So our data validation is from my experience, the most common element of, you don't need to test that you can actually save a string value into the name column on this table. That's just SQL Server stuff, and we don't need to test SQL Server stuff. But my issue is that's normally going through a lot of additional code. We're going to have things like command interceptors inside of Entity Framework or inside of Hibernate that's going to check, hey, whenever a new user is saved, do this other stuff. Common tasks that we're doing on every single save that we don't necessarily want to litter our code with. Things like maybe we have audit columns on every single table, and that audit columns has a last updated on timestamp and a last updated by that's got the current username in it. And you've abstracted all of that stuff away into an interceptor in Entity Framework or in Hibernate, so that whenever a user class is saved, it's automatically manipulating those 2 columns and you don't have to worry about it. So there's other code that's happening as a part of the save process. It's not just SQL Server writing down a new string into the name column. So that stuff we should also wrap under test too. For this data validation, we're just going to focus on Fluent and Hibernate for this one. For this first one, Fluent and Hibernate is a Fluent syntax that can sit on top of Hibernate. This functionality here has been available inside of Fluent and Hibernate since version 1.3, even though they're well into version 2. A good example is map testing, property testing. So with Fluent and Hibernate, inside of your unit test, you can new up a new persistent specification object. And inside of that spec, check all of the properties. check property org.name and give it a value. Check property org.description and give it a value. Check property org.isApproved and give it a value. However you want to specify these, whether my name is hard-coded or you're using a different library that'll randomly generate a new string, whatever. And then verify the mappings. Verify the mappings under the covers is going to initialize a new object, set all of its appropriate properties based on what you've specified, save it to the database, going through all of your existing interceptor logic and whatever things that you have in place, clear the ORM's cache, and then reload it from the database. So that the reload isn't just going off of the stuff that's already in the application, already in the web server's memory from a previous cache request. It's refreshing the entire thing on the database and verifying that the property that we specified before is the property that came back from SQL Server. So it's a good high-level integration test to make sure that all of your saved process code is executed and returns back exactly what you think it is. Because it's handy for even things that if you, let's say you don't have any schema validation tests in place, maybe the description column is, I don't know, you've set it up by mistake to only store the first 20 characters. And you go and you think that it's a varchar max, it's an unlimited column, and you can store 1,000 things in there. Well, by doing those property validations, you can check and make sure that the entire value was saved and the entire value came back, just as an example. And then doing some save testing in very similar ways, but more drawn out. I'm just going to use nhibernate for an example here, but the code structure would apply almost identically to things like Entity Framework Core to save something and then do tests to make sure that the expectations were met. So in this case, we're creating a new department off of an empty database, but a department belongs to an organization. So not only when we create a new department called my department into the database, since it's empty, an organization is required, we need to create an organization as well, my organization. We save it, all of that stuff is wrapped in a transaction because there's just one connection. We need to maintain the same existing connection in our in-memory stuff. So we do all of this through transactions. And then as a part of our test, maybe we want to test our cascade functionality, making sure that we set up our cascades properly inside of our database. So after we've went and cleared the session, now we go and delete that same department and commit that transaction. Our unit test should make sure that when we deleted our department, the department's gone, but the cascade delete didn't also take the organization with it, because just because we've removed one organization from a department doesn't mean, just because we've removed one department from one organization doesn't mean the whole company's gone. Just that one department went away. So as an example of things that are still our code, we trust that SQL Server Cascade Delete is going to work just fine, but we can't trust that we properly configured Cascade Delete. Maybe we set the wrong Cascade Delete flag and everything's going to be broken now. So good opportunity for not testing SQL Server as an engine, more testing the way that we've configured our system to try and consume it. So through all of this, through things like that schema validation, through things like our migrations, through things like those data mappings, persistence mappings, allows us testability inside of our system, that allows us to be able to write tests that we can verify things, that gives us the automation for deploying, for the repetition, for testing our migrations over and over and over again, so that the first time that we're running these migrations isn't deployment day, when we're all hanging out at 2 o'clock in the morning trying to figure out what went wrong, because that's the only window we have to run the deployment. We've already executed through unit tests this deployment 5,000 times before tonight at 2 o'clock in the morning. We know that it works. And if something goes wrong, we also know that the recovery process works as well, because we're nowhere near as effective at 2 o'clock in the morning as we are at 2 o'clock in the afternoon. I hate to be trying to figure out what went wrong, and even more importantly, how to put it back when I'm tired at 2 o'clock in the morning. I just want to have a proven process that I know works, that I can click on one button, roll back, and all of that existing known proven functionality just works. Because to me, that's how we get database confidence. Certainly, of course, afterwards, again, if tomorrow, after you hang up, you have the best questions, feel free to just reach out to me on Twitter or make a comment, database confidence, and I'll see it, or shoot me an email, j@aranasoft.com. But I guess for now, does anybody have any questions? I know some of it was a lot, some of it was a little deep and codey, but does anybody have any questions on any of this stuff? No, I know most people are using Entity Framework Core, certainly over and Hibernate. We use both. For us, Arana Software, of course, we're a consulting company. We build whatever platforms that our clients want us to build on. So sometimes that's Hibernate, sometimes that's Entity Framework. We're certainly have familiarity with both. That last example was in Hibernate, just because the code is largely identical between Hibernate and Entity Framework code, and it wasn't really value to add slides of, yeah, and you do the same thing the same way. So it's just context.delete instead of session.delete. But other than that, yeah. And if you have any questions sometime later, feel free to shoot me a line. Thank you.
Jay, let me ask a question. It actually doesn't pertain to your talk. The question I got privately during the talk. So someone was asking, he was telling me that he's experienced in doing, basically ASP.NET. Wants to learn ASP.NET Core. And he was asking some advice as to where should he look for some resources. He's been looking at Pluralsight, which I told him that's a great resource. I told him to check out Coach Pitsky's workshop that he'll be doing at Codepalooza, because that's always been a winner. I was curious, you or Rob Richardson, I know Rob's in the audience, if either one of you two have some other suggestions.
He's just starting out in .NET and ASP.NET Core?
Sounds like he's just starting out with .NET Core.
Okay.
So he's, because he's let's see here. Let me look at this. So I'm currently supporting and doing some dev on a legacy ASP.NET app, but wanting to modernize my skill set. Currently going through MS Learn and Pluralsight courses for Azure and .NET Core. Do you have any other recommendations?
Certainly docs.microsoft.com as well. Microsoft has done a phenomenal job over the past couple of years on building out their documentation around the platform as a whole. It was less than great 10 years ago. Even though we're quickly approaching 20 years on .NET as a whole. 10 years ago, it was less than great, but it's really good. It's really good now. Yeah, that would be where I would start. And to most people, if they're just getting started with ORMs, if they don't have any experience with either Entity Framework Core or Hibernate or really ORMs at all, I'd recommend Entity Framework Core, just because there's so much more documentation around it. Really, documentation is the key. Documentation is by far the key. I was working with a client on just today, working on a client project where we need to go download some files, and we're putting inside a .NET Core on an Azure function that can just run a scheduled trigger to every day at noon go get this file. But the file is in, or the FTP process, of course, it's downloaded through FTP, but through secure FTP. The current implementation is SSH FTP. And there's certainly the core libraries, the core .NET stuff coming out of Microsoft doesn't support any of that stuff. So it's third-party libraries. And choosing a library for this stuff is all going to come down to documentation. I need to be able to build this integration with SSH FTP to go download this file. And I can, and oftentimes I'm going to have to dig into your GitHub repository to figure out how you're doing this thing, but I don't want to have to do that on the Hello World example. You know, initially starting out of just go download this one file and you're done, kind of opening intro, that should be well documented. And Microsoft certainly is miles ahead of everything else when it comes to documentation. Also makes the Googles better too, because Stack Overflow can sometimes get a little long in the tooth since it's got questions on it that are 20 years old or more now.
Well, and bring up a good point. When you find an answer on Stack Overflow, look at when the answer was written.
Right. Step one is look at the timestamp on the question. Yes. Microsoft documentation along those lines. The date is prominent at the top of the document, and under most applicable scenarios, it'll also show you exactly which framework that this applies to. If this is still on .NET 4.5.2, if this is on .NET Core 2, if this is on .NET Core 3 or 3.1, it's showing you right in the header what version of the framework, which framework, full framework or core, and which version of that framework that this thing applies to.